This double bond doesn't get touched. And then this double bond right here, we used it to attack HBr. So where are you going to put the plus charge in the intermediate? You got two choices, don't you?
Yeah.
At the bottom
you
one.
You can put it here or you can put it here. If you watched the video yesterday, where are you going to put it?
The top.
Actually, you're going to put it here. Right? And that's the difference in reacting this with a conjugated diene versus just a regular alkene. This is the key intermediate for this reaction. Right? It's an allylic carbocation. It's got to be that. So the plus charge has to be allylic. Go ahead, Kayla.
How about that? I came to a realization.
Okay. We all do we do remember the definition of allylic, right? It's adjacent to an alkene. So here's my double bond, and then the carbon that's next door to it is the allylic carbon. Is that okay?
Mm-hmm. Yeah.
Undergo resonance though too, right?
Yeah.
Just form two.
Yeah, and that's exactly why this carbocation is favored over this one.
Okay, got it.
Even though this one would be, let me change the color on that because I don't want to confuse nobody. Even though this carbocation up here is tertiary, right? You got a secondary carbocation here, but it's stabilized by resonance. So that's why this one is going to predominate. And you may actually get some of the other product, but for the most part, it's going to be here, right? This intermediate is common. It's common because see, with this reaction, you're going to get two different products, right? So bromine is here, right?
Mm-hmm.
Are we following that? It's kind of a lag, so maybe
Yes.
Maybe it's my Wi-Fi. Come on now. All right. So when bromine is here, bromine can attack directly at the plus charge. Come on, man. I feel like I'm making a Khan Academy video. This thing is slow. I don't know why the connection is so slow. Let me stop it and restart it. Maybe that was a bad idea. Okay. All right. Still got a little bit of a lag. Right, so my bromine can attack directly here. Right, this double bond didn't get touched. And then the methyl group is still here. Is that okay?
Yes.
All right, so this, we're going to call this direct attack or 1-2 attack. And I'll explain the 1-2 and all that stuff in a minute. Right?
What's that word above attack?
The word above attack?
Yes.
Oh, direct.
Oh.
My bad. I keep saying I'm going to buy a stylus, but every time I do, it's just awkward. So I just use my finger. That's frozen again. All right. So, Jalen, you said something a second ago about resonance. Is that right?
Yeah.
So, what would the resonance form? Where would you put the arrow? Can you write on your screen, or no?
I'm on my laptop, so I'm not.
Okay, you can't write it. All right. So, yeah. if I were to draw the resonance form, would the arrow put an arrow right there? Come on, it's coming up. It's just lagging.
Yeah. And then the plus charge will just shift to the left.
It will shift over. Is everybody okay with that? Do y'all remember that from part 1? And all semester we've been doing resonance.
Yes.
Resonance is never, it'll never die. It's eternal. All right, come on, it's coming. It's just lagging. I don't know why it's slowing down like that. All right, is that right? Can you see that, the resonance form?
Yeah.
Yes.
Okay, so can bromine attack that plus charge?
Yep.
Yeah.
It can. Right, so with these conjugated dienes, you're always going to get 2 products. You're going to get the product where bromine attacks directly. It's coming up. Oh, come on, man. And then one where bromine attacks the resonance form. So I'm gonna draw that down here. Yes, no.
Yeah.
Yeah.
We're gonna call this resonance attack. Or 1,4 attack. All right. So anytime you have a conjugated diene, you're gonna get those 2 products. You're gonna get the direct attack and the resonance attack every time. And that's one of the reasons why. The reasoning for that is that allylic carbocation, once you form it, it's gonna also give you the resonance form. So you're gonna get 2, basically be working with 2 cations, and the bromine can attack at either one of them. All right. If you watched the video on yesterday, you'll know that you can control which one you get based on the temperature.
Yeah.
Yeah. So it's a temperature control reaction. So if I do the reaction at low temperature, right? So 0 degrees, that's just an ice bath. If I do it at low temp, then I'm going to get this product as the major product. Right. So at low temperature, it's the direct attack product. And then if I increase the temperature, then I'll get the resonance product as the major product. All right. And that goes for any conjugated diene. If you do it at low temperature, you're going to get direct attack as the predominant mechanism. And then if you do it at high temperature or higher temperatures, so you can increase the temperature, you'll get the resonance product as the major product. All right, I'm gonna pause right here. Any questions about this?
So at low temperature, we're gonna get that initial product. So would that be considered the kinetic?
Yes.
And then thermodynamics would be the second
So
one.
at low temperature, you're right. This is the kinetic product. It just means that the activation energy to get to that is lower than it is to get to the other one.
Okay.
And then the bottom product would be considered what we call the thermodynamic product.